You guys, I have another board here. It's HP board, HP Elitebook 840G34. Yeah, and there's no power, so we are coming to fix it. So let's try. Let's test it. No, of course, there's no current reading. We don't have any reading current or amps, so which means the 19 volt is not going. So let's test whether we have a 19 volt, 19 volt on the board. Let's test it from here. It goes here. The charger port is passing here, from here to here. So you should check it from here. 19 volt is present here. It's not present here. Yeah. What? The output of this MOSFET it's giving us a 4 volts. Then which means you have a low gate. This is the gate. So which means here is very low. Yeah, we have the same 4. Because here we should get 19 volt or 24 volt. So that's the same amount of power here to pass it here. So if we have a 6 volt here, here will be 6 volt, 10 volt here will be 10 volt. This amount of the gate power we get from here will determine the power this MOSFET will use to pass here. So it's maybe from 19 and above because the current is already 19. So if we get 30 volt for here, still 19 will pass because the charger maximum is 19. So normally it's 24 volt here. But if it is 10 volt, 5 volt, and then the same amount will come here. The same amount will receive here will come here. So here the gate is very low. So therefore, which means the power management I see is not doing the great job. So let's put it on the continuity in a bit mode. So let's raise some voltages. Reduce some ohms here. Ohms, of course. Yeah, it's correct. That's correct. The gate also correct. Let's check the gate. The source also correct. So then let's check this one. Also good. The gate good. And the gate is okay. Also good. So then this is our problem. I am telling you, this is the problem. So, because here and here are together, this gate and this gate, it's on a yeah, parallel mode. It's on a parallel mode. So the same amount we get here, also the same amount this one also will get. So this gate and this gate are connected, so they are always receive the same amount of power because here we use the 19 to pass, here also use the 19 to pass, so the same amount will come here. Why don't you loop it for this? Because this is the same amount this one should also get. This one also get 19 and above to 24 volts and above. The same applies to this one as well. So then in knowledge, we shouldn't separate this gate and this gate because they are always doing the same job. The expectation are the same thing. So they link it to this one, so they are the same. If this one receives 4 volts, like what we saw from the beginning, then which one? The same amount of 4 volts are coming here. Yeah. So this is the power management I see. This is the BQ. BQ is giving this gate a 4 volts. Then which means it's working, but it's not doing the good job because it has a voltage. So let's check something here. let's see, we should get a 19 volt for this IC. As you can see, we have a 19 volt, then which means this IC receives power. Like as usual, should get the power from backdoor. Like the power from charger is here. When it goes here and here, between from here to the charger, that IC should get the power from this place, the back door. You understand? You shouldn't get the power from here or here. Then who is going to control this once? So this IC get power from the direct from the charger, and you used to control these two people so that you can, send the voltage to the board. So it will receive power. So then you don't have any problem. Then you have to change this thing. You have to change it. So let's see whether we can get a different board for them. This thing I can bridge it from here to here. I can solder a wire from here to here, but it will work. But I think we will be having a problem charging on charging circuit place because this IC it's working here in the charging system. It's working on two ways. Yes, to make sure that these two MOSFET are working perfect to bring the 90 volts on. At the same time, this IC is charging the battery. So if this IC is not working properly and I loop a wire from here to here, and then I think we're going to have a problem on the charging side. So let's see. Let's try again. Why is this any IC I put on this? It gives charger. Then we come with the 12 volts on the gate. So 19 volts will be on the gate here. So the machine is on. You can see it. It's on here. So yeah, that one machine is working. Why we don't have a 20 plus or 19 plus on the gate? And I've changed so many. Do you think ICs on those boards are not correct or what? I don't think so. This IC should provide 24 volts for the gate. I couldn't. And I've changed two times, still the same behavior. And what's going on? Those that board are not good. It's working. Okay. The fan is spinning normally, so which means it's working. Yeah, check. It's working fine. So we fixed this one. It's a very little complicated, but we did it. We are praying that the power management IC should charge the battery. These are our worries. Because I don't know reason why I've changed almost three ICs. Yeah, it's a two IC. And still behaving the same thing. So plus the original one, which is on it from the beginning, also giving us a 4 volt for the gate. I changed. I took one of the IC from the donor board and then I replaced it. It also gives us 4 volts. Then I also took another board, the same board, and I also took the IC and I replaced it. Also give us a 4 volts. So I don't know reason why giving us a 4 volts for the gate or the what do you call it? MOSFET. First MOSFET and second MOSFET. They are together, they're linked together. So any voltage which first MOSFET will receive, the same thing the second MOSFET will receive because they are linked together. But the IC giving us a 4 volt, which is not fair. I don't know reason why. Three ICs giving us the same thing. So I think I don't know because all the donor board I took, it's a dead board. So I don't know. This is the fault of this kind of Elitebook G3. Maybe their normally problem is the power management IC, which is giving us a low voltage for the gate. Maybe I think so because there's no problem on this board. If it was a problem, if it was a problem, it wouldn't even work when I bridge the main power from the charger to the. it won't work when I bypass the first MOSFET. So which means there's no problem on the board. So it's the IC. It's the same as. Okay, now we fix it. So thanks. So just once again, I'm here today too, and if you remember this one, we did it, and it was no power, and I did some readings. I checked, and I found that there's no power crossing the first MOSFET, and then I checked the BQ, the power management IC. It was having a power, but there's no power on the gate. I think the gate was 4 volts, 3 point something. Let's say 4 volts. Yeah, is it 4 point something or 3? Yeah. Okay. So that current will not can't even power the board. It will never power the board. So I changed. I took some donor boards, I think 2 or 3 donor boards, and I took the IC and I changed it, the same result. I took another one, I changed it, the same result, giving us a 4 volt for the gate, for both first MOSFET and second MOSFET. So I'm just assuming that the donor boards I'm having here, the problem of it is like the same problem. Like the power management IC is not correct as the same problem that we have. And so uh, yesterday I went to shop yesterday and I took another board and then it's here. So we are coming to take the power management IC. This one you don't have power jack, but when I inject the power at the first MOSFET, the current passed through into the board. So we have 19 into the body, but this board is a donor board. It's not correct. Yeah, but we have a 19 volt in the main board. So which means the IC is doing the job correct. So we are coming to take the IC out and replace it to this one. So let's do so you can see, you have flux over the IC, all around the IC, and I just did bridge from here to main source. As you can see from the charger, it goes here, pass here, come here. So I bridge from here to here, and then we had the current going across all over the board. So this is the power management IC. So this one we are going to change it. The working one. Let's see. Same result. Then which means something is not right. Oh, what is this? Why this one is going, but I checked before. It wasn't like this. This one too. Oh, what's going on? Okay, let's see. Yeah. I think you get it. You got 1 million, 7 million. But want to start or not? Oh, we have BIOS IC. BIOS battery. If you have a BIOS battery, then yes, everything is working because without BIOS battery, it has to, yeah, it has to start it by its own. But we have BIOS battery inside, so the board will never start unless you press the power. So we have, sorry, so now we have a 19 volts. But what? Because yesterday I just checked two of them. No one was shorted. Two of them, no. And then after today, after I changed the IC, the second MOSFET was shorted. Or it shorted the whole time. Then I didn't see it because I tested it. What's going on? Okay, let me check the main power. So we are going to disconnect that cable. This one. Let me check it from the current sensor here. Yeah. Oh, let me switch to booting. Let's go. Yeah, we have 19. God. Yesterday. So now this board can charge the battery. So let's put the battery. The thing is this. So we have to turn it. Yes. So let's now this. Oh yeah, it's charged. Yes, you can see. Check. Let me use my hands to check. Check. So now we have for 142 million. Then which means it's almost full battery. Yeah, and then the battery is full, of course. So done with this one. Let me remove the cable, the wire, the nutrition wire. The 19 volt will come and stuck at the first MOSFET. And the first MOSFET need approval from the BQ, power management IC. The approval will depend the amount of current the BQ will send into the gate. Yeah. The maximum power is 19. So if you send 19, the MOSFET will carry 19 straight to the board. If the gate receives 18, the MOSFET will send the 18. Receive 5 volts, you send the 5 volts. So therefore, which means in this case, the main power was 4 volts. Because of gate, was 4. Do you understand? Yeah, so I changed a couple of what do you call it, BQ power management. I said that's the same results. And then I decided that maybe my donor board was having the same issue because it's a donor board, it's not working. So it's there to mean taking some component out for the new machines to be working on. You have to take a component from the donor board to replace the new one. So I thought it was maybe it's also the same problem. It's a power management problem. Then I went to shop and then I just took another board which is working fine, but it's not working. But we have a what do you call it, power in the main power rail. Then which means the BQIC is working, but in other cases part is not working. So if the BQ is sending the 19 volt to the board, yeah, then the BQ is correct. Then I took the board, then I changed the IC. It's giving us the same result, which is 4 volts for the gate. So cost 90. Then then I started checking some components. So I checked the first and the second, and I found that the second MOSFET was short, was shorted. How? Because at first I was checking all the stuffs. I checked first MOSFET, I checked second MOSFET. Everything was fine, but now it's shorted. So I don't know reason why the second one. I don't know. So during the transferring the what they call it, the MOSFET, or it's yeah. Now I get it. I get it. I get it. It's because we bridged the first MOSFET, and now the current was pushing straight to the second MOSFET, and so the second MOSFET don't have any option to connect the bridge like a fuse. So it's not working again. So it's constantly bridge like a fuse. Yeah, I think so because I bridged the first MOSFET. That's why the second MOSFET was shorted. Okay, that's good. So the second IC is working fine, and I changed the second MOSFET as well. So everything is fine. It's charging. It's working perfectly. So next time. Thank you.